So today in class we did an experiment with some rice and some things like that, and we found that the volume of a pyramid or a cone is 1/3 the volume of a prism or cylinder. It took 3 of these pyramid and cones to get into the prism and cylinder. Remember, we did that with the rice. So that's the big deal, which means this is going to build us a theorem every single time. It means that I can always find the volume of a pyramid or cone by saying it's 1/3 the area of the base times the height of the prism. And that'll work for every single pyramid and cone. The key is remembering that 1/3. It's easy when you get doing problems to forget that part of it, especially when we mix these up. So the nice thing about this is it's always going to be true as long as the pyramid and prism have the same base area and height. Then this will always hold true. If the base areas are different, well, now they're not going to, that 1/3 isn't going to be perfect. If the height isn't different, that 1/3 isn't going to be perfect. Okay, so that's something that we got to look out for. But it does lead us to another theorem about all of these. If I've got 2 prisms, or if I've got 2 pyramids, and they have congruent base areas and congruent heights, then they're going to have congruent volumes. Here's the neat part. Even if the bases are different shapes. That's the really cool part. As if I've got a hexagon base, if I've got, let's grab 2 things here. If I've got a base that's a hexagon and a base that's a pentagon, as long as these 2 things have the same area, which in this particular case I don't think they did, but as long as they have the same area and then the prisms have the same heights, then they're going to have equal volumes, even though they're different shapes, because of that formula of base area times the height. The formula doesn't know what the shape is, so that's why this works. So you can sort of play with problems that way very easily. So real quickly, let's try some examples and see how this works. So find me the volume of this and find me the volume of that. Okay? Take a moment to do that. So the volume of this, we said the easiest way to do rectangular prisms is length times width times height. We talked about that in class the other day. So that's 4 times 3 times 8. Again, it doesn't matter what you use for your length and width and height. It's going to work out because multiplication is commutative. So that's going to give me a volume of 96 cubic centimeters. Now this particular problem I need to think of a little closer. My base is a triangle, so that's 1/2 base times height. So that's 1/2, 4 times 6, and that's going to give me 12 cubic centimeters. So my volume of this is 12 times 8, and 12 times 8 is 96 centimeters cubed. Notice they have the same volume. Notice what else is the same. If I use 8 as the height, they have the same height. If I get the base area of this, the base area of this piece, 4 times 3, is 12. Whoops. And we said the base area of that is 12. So here's 2 prisms. They have the same base area, they have the same height, so they're going to have the same volume, even though they have different shapes. So it's that base area that makes the big difference. Okay? Try the next problem. Find me the volume of this shape. I'll give you a second to work on it. Remember our formula at the top of the page. Okay, so our formula for volume, we're now dealing with a pyramid, is 1/3 the area of the base times the height of the pyramid. So the base is a rectangle, so length times width. So that's 4 times 3, so my base area is 12. So that's going to be 1/3 of 12 times the height of 8. Hey, take notice of what we've got here. 4 times 3 times 8. That was just what we had up here. These 2 figures have the same base areas and the same heights. So this figure is going to be 1/3 of that figure. So it's going to be 12 times 8 divided by 3 gives me 32. and that's centimeters cubed. So there's an example where we can see, if I recognize that base area quickly, then I can just go back up to my top problem here and go, oh, it's 1/3 of 96. Okay? So honestly, I don't often see that. I usually figure it out like this. Okay? So let's take a look at a couple more things. Let's talk about our cone. Try and find the area of this cone. Go ahead and round your area to 1 decimal, because that'll make it easier to type into the problem here. Okay? Give this a shot. Find me the volume of this cone. All right, so volume, again, 1/3 area to base times the height. Well, again, I know my area to base is a circle, so I'm just going to rewrite that as pi r squared times the height. So that's 1/3 pi 2.1 squared times 6. Well, 2.1 squared is 441 times the 6 divided by the 3. So I get 8.82 pi. And again, I like to write it like this. And now that I'm all done, now I'll multiply by pi, and that'll give me my rounded answer. So I got 27.7088, round it to 1 decimal. So we'll call it 27.7 cubic centimeters. Okay, so that's pretty simple. Remember that for volume of pyramids and cones, we need the true height, not the slant height. Okay, that's really important. When I looked at the volume of this cone, I want that true height. I want the height from the base to the apex. Okay, so from the base to the apex. That's this point way up here. It's called the apex. We want it to be a right angle with the base. We don't want this slanted height here. That's not going to work for us. So when I'm trying to get these problems, if I'm given the slant height, I need to find the true height. We used the slant height earlier when we were talking about surface area, but now we need to think about the true height. So be careful that you're using the appropriate measurements. In this particular problem, I'm given the slant height. So I need to find this true height. I'll call it height of the cone. Let's call it height C for cone. Well, you might recognize this. I could use Pythagorean theorem, but you might recognize this as a 5, 12, 13. If you didn't, you could certainly use Pythagorean theorem. But either way, you're going to get that the height is 12. Okay? So now that I know that this is 12, now I can find my volume. 1/3, got to remember that 1/3. It's so easy to forget. Area to base, pi r squared, times the height. So 1/3 pi 5 squared times 12. So let's see, that's going to be, well, 1/3 of 12 is 4, and 5 squared is 25. Oh, hey, I can do that. That's 100 pi. Okay, so 100 pi meters cubed. That one I'm not making you type in because I wanted to go over what that height was. Okay, so that brings us to a recap. Volume formula for prism, volume formula for cylinder, volume formula for pyramid, volume formula for cone. Go ahead and give me what those formulas are. Try to remember them. Okay, so to recap, for prism, area to base times the height. For a cylinder, area to base times the height, which you could write as pi r squared h. For pyramid, the volume is 1/3 area to base times the height. For a cone, 1/3 area of the base times the height, which you could write as 1/3 pi r squared h. Okay, so there's different formulas you could use. If you remember this and that, you're pretty much set, even if you don't remember these. Area to base times the height. All comes down to knowing the area to bases. Okay, great work. We'll see you tomorrow, and we'll look at some problems with cones and pyramids.